This is all about filters. Now, what is a filter? Filter is a frequency selective circuit. So that means filter is just like a sieve that can select a particular frequency and reject all other frequencies. So it is a frequency selective circuit. First of all, what is a frequency selective circuit? As I told you, you have a sieve in which you pour the tea into this and you are left with the tea here and the tea goes into the cup here, right? So you have a sieve जो आप छन्नी यूज करते हैं, this you pour tea into this and the tea leaves are filtered out. So tea leaves remain on the top and the tea comes here in the cup. So same role is performed by the filter in communication circuits. It selects a particular band of frequencies. So it selects a band of frequencies. If it is a band select filter, so it selects a band of frequencies which are specified. So that means if we have designed a filter to select a particular band of frequencies and at the same time it rejects or attenuates. What is attenuation? Attenuation is the drastic reduction in the amplitude of a signal. So it rejects or attenuates undesired frequencies. That means the frequencies that are not required, they are attenuated or they are filtered out. The rest of the frequencies, they go to the output circuit. So if we want a particular set of frequencies to go to the output, then we can make use of a filter. Now, filters can be categorized into two types on the basis of various parameters. So one type of filter can be analog filter and another type of filter can be a digital filter. So what is the difference? The difference between the two filters is that analog filter, they are used to process analog signals digital filters also filter or process analog signals. Now what is the difference? Both of them are processing analog signals, but the difference is that a digital filter processes analog signal using digital techniques. That means we are using some software techniques which are also called as windowing techniques or some algorithms in a digital filter. While in case of analog filter, we are using physical components such as resistors, inductors, capacitors. In addition to that, we can also make use of active components such as transistors, MOSFETs. Transistors, we have MOSFETs, FETs, BJT, etc. Right? So first categorization of filters is on the basis of the nature of processing that the filters can do. Is it clear to all of you? So first classification is on the basis of the nature of the filtration. Second, am I audible to all of you? Students? You can turn up.
Yes, sir.
Okay. So classification of filters is on the basis of analog and digital. And components such as R, which are called as passive components. In addition to that, we can also make use of active elements such as transistors. So, but in case of digital filter, the processing of analog signal takes place again, but using digital techniques which are also called as software techniques, or we have certain windows that we are using. You will read in the digital communication that there are some windows that are used for filtration of signals. Second classification is based on the nature of components that we used, that we use in the filter. So depending upon whether we make use of passive components or we make use of active components, the filter will be called as passive filter or it will be called as active filter. Now what is a passive filter? A passive filter generally makes use of components R, L, C, which are passive components. So in case of active passive components, we make use of RLC. Generally, L, which is an inductor, it is bulky and costly. Because of this reason, most of the passive networks nowadays, they make use of only R and C as the components, and we make what we call as ladder networks out of this. So ladder means a combination of RC networks which are cascaded, which are joined together to make higher order filters. Right? I will discuss this parameter order with respect to filters. Active filter. Now, what is an active filter? An active filter will make use of RLC. In addition to RLC, it will also make use of active elements, as I told you. Also, active components such as transistors, or we may also make use of active elements such as op-amp. In this case, the type of filters that we are going to design, we are going to make extensive use of op-amps. So first classification of filters was on the basis of analog and digital technique. Second was on the basis of the components that we use. So we have passive and active filters. Then third classification is on the basis of order. We will discuss that later on. Order of the filter. Now, order of the filter means how many networks it is using. It depends upon the roll off rate. What is called as roll off rate. I will discuss that. So, order of the filter signifies that we can have first order, we can have second order, third order, and so on. Right. So first order will comprise of only one RC network. So if our filter circuit has only one component, one resistance and one capacitor, or one RC network, we have only one R and one C, then it is called as a first order filter. Another way of identifying a first order filter is that if the roll off rate in this case is plus minus 20 dBs. 20 dB means the gain increases at the rate of 20 dB plus dB, and it drops at the rate of, if it increases at a speed of plus 20 dB per decade. What is 20 dB per decade? Decade means for every 10 steps increment in the frequency, if the frequency increases by 10 steps, then the gain is going to increase or decrease at the rate of plus minus 20 dBs. So that is called as plus minus 20 dB per decade. So if the roll, this is called as the roll off rate. Why do we call it roll off rate? Because the gain increments or decrements at this rate, and it is increment is plus 20 dB per decade, and decrement on this side, this is decreasing side, this is increasing side. So the roll off rate is plus minus 20 dB for a first order filter. Similarly, for a second order filter, we are using two RC networks. So if we make use of two RC networks, yes?
Sir, your screen is not visible.
What is happening?
Sir, your video is paused.
Video pause हो गया? ठीक है, मैं चेक कर लेता हूँ. I'll check out. Screen आ रहा है? Screen दिखाई दे रहा है? Screen is visible to you?
Yes, sir, it is fine now.
ठीक, okay. तो मैं बात कर रहा था, I was discussing about the classification of filters. First of all, filters are classified as analog and digital. Second, based on the types of components that we are using, this is second classification. If we make extensive use of only RLC components, और RLC में से मैंने आपको बताया, if we generally we make use of R and C because an inductor is costly and it is bulky, therefore we drop an inductor in the IC design. We only make use of RC, so that is called as a passive filter. If we make use of RC plus passive components plus an active component such as a transistor or op-amp, then it is called as an active filter. Now third classification was on the basis of order of the filter. A first order filter has only one RC network. A second order filter can look like this. We can have two RC networks at the same time. So if we have two RC networks, then the order of the filter will be 2. Right? In this case, the roll-off rate will be plus minus 40 dB per decade. We can take it in terms of octave also. Sometimes you see we write it as per octave. Octave means for every 8 steps of frequency increase or decrease. Sometimes we take octave, right? So that is our way of doing it. Generally, when we plot the frequency response, I told you the meaning of frequency response. Frequency response is a plot of frequency, logarithm of frequency along x-axis and versus voltage gain in dB. So on along y-axis we have voltage gain in dB, decibels. What is voltage gain in decibels? It is 20 log of mod of voltage gain. So if A is the voltage gain, then 20 log of A will convert A into decibels, right? So why do we apply log to the frequency scale? Can anybody tell me why do we apply log to the frequency? What is the advantage? Yes, anybody can answer this question. Why do we apply logarithm to the? Why do we apply log to frequency here? The answer is quite simple. Answer is to compress the scale. So in case we want more information to be plotted on a piece of paper, then we express that quantity as logarithm of that. So this is called as compression. And if I apply anti-log to anything, we can have a microscopic view of the same thing, right? So three techniques of classifying. Then one more technique of classifying the filter is on the basis of, this is the fourth classification. This is on the basis of the frequency of operation. So on the basis of frequency of operation also we can label a particular filter. So filter can be audio filter, or if our filter works on the audio frequency, we can have an audio frequency filter which is called as AF filter, AF and RF. AF signifies audio frequencies. What is the range of audio frequency? Audio frequency ranges from 20 Hz to 20 kilohertz, and anything above 20 kilohertz is radio frequency, which is used for communication. So if our filters, generally we select this as 0 Hz sometimes. Okay, so if our frequency design, our filter is designed for this frequency spectrum, then we call it as audio filter, audio frequency filter. And then in this case, we generally make use of, for low frequency, these are called as low frequencies. For low frequencies, we generally make use of RC filters. So in the filter structure, we make use of RC filters. And if we have to make high frequency filters, sometimes our need is high frequency. So greater than 20 Hz is high frequency filters or RF filters. Then in that case, we make use of LC filters. If you remember, in the oscillators, for low frequencies, we were making use of phase shift and Wein bridge. Here we were making use of phase shift and Wein bridge. Do you remember? So this was for low frequencies, and For high frequencies or radio frequencies, we were making use of Colpitt's oscillator. We were making use of Hartley, right? And Clap. These were high frequency. And if we want to go further, very high, then we can make use of crystal oscillators. So crystal oscillators are very high frequency oscillators. But since we are discussing filters, in case of filters also, we can have low frequency filters, which are called as audio frequency filters, which make use of audio frequency filters, make use of which components? They make use of RC components in the network. If we want to increase the frequency or we want to operate the filter at high frequency, we will make use of LC filters. Now, after this, we will discuss what are the advantages of active filters. Now, in our course of integrated circuits, we have to study active filters. Right, so I have told you what are various types of filters. Have you understood various types of filters? What is the advantage of filters and how filters are classified? Okay, so active filter has the following advantage. First of all, we have gain and frequency adjustment flexibility. Why? What is the reason for this? Can anybody answer this question? Anybody can elaborate? In active filter, this is one of the advantages. Yes. Who can explain this point? Gain and frequency adjustment flexibility. Why? What is the reason? Second advantage is no loading problem. Gain and frequency adjustment, why is it there? Because we are making use of op-amp, and you know in op-amp we can adjust the gain. We can adjust gain and we can also adjust frequency. So this is one of the advantages, or this is called as fine tuning. We can fine tune our op-amp as per the requirements. We can make it work for a particular frequency. No loading problem, you know, since the op-amp has bought Z in is very high for op-amp, and you know it does not load the source, right? That means even if the signal which is coming to, if a very small signal is coming to a active filter, I told you it is a combination of active filter is a combination of R, L, C and plus active elements such as op-amp. Here we are taking op-amp as the element. So because of this, there is no harm to the signal. That means even a small signal can be processed by an active filter, right? So these are the advantages of using an active filter over the passive filters, that we can adjust the gain and